Assalamualaikum warahmatullahi wabarakatuh and salam sejahtera. I'm Rhahimi binti Jamil from Polytechnic Tunku Sultan Bahia, Kuala Kedah. Today I would like to present about my study, a review of removing Escherichia Coli growth in river water by using riverbank filtrations. Escherichia Coli are also known as E.coli. For introductions, in Malaysia, Malaysia rich of groundwater as a source of the water for our country. Its demand has been projected to increase by 60% from 2000 to 2050. It's become a highly salt water source in the recent year. For the riverbanks, filtration for RBF is one of the groundwater abstraction technique that has proven and has long been recognized as a natural method for surface water treatment. It also an effective method of removing pathogenic bacteria and viruses during the infiltration. The result is the removal efficiency of microbial contaminants at different locations are varied, with less than 2.1 logs removal for E. coli and more than 3.2 logs removal of viruses. Some improvement of enhancements with other treatment techniques can be increased by using RBF efficiency. So for the literature review, we divided into four type of pollutions in drinking water source. The first is organic substance, which is sewage, feces, and food waste. Then toxic substance, pesticide, plastics, industrial compounds. And thermal pollutions divided by two: discharge of waste bead, cooling, and heating. And the last one is ecological pollutions divided by two: organic material in flood and volcano eruptions. Okay, this table shows the microorganism in drinking water sources. This is modified from Crittenden et al. 2012 and Ibrahim 2018. We divided by three, which is types, description, and remarks. From this table, it shows the type of the viruses and bacteria, such as bacteria, Vibrio cholerae, E. coli, Legionella, Shigella spp, and Salmonella. Description of this bacteria. This bacteria is a single-cell organism with a size range from 0.1 to 10 micrometer. Negatively charged surface, aerobic and aerobic facultative, motile and non-motile. For remarks, the most reported waterborne plaques involved of bacteria. For protozoa, Cryptoporidiums, Parum giardia, Lambia, Entomobia, Dispade, Entomoeba, Histolytica. For descriptions, a group of unicellular and non-photosynthetic organisms with a diameter size between 1 to 102 micrometer. Negatively charged surface, aerobic and anaerobic, motile and non-motile. For remarks under waterborne disease standpoints, the four listed protozoa are considered as the greatest risk in the water supply. Okay, this protozoa we usually found it in our water supply. For viruses, T4 coplepage, adenovirus, enterovirus, rotavirus, and MS2 coliphage. For description, smallest of waterborne agent with a diameter size of 0.02 to 0.2 micrometer, negatively charged surface. For remarks of poliovirus and hepatitis A are the only known virus that have been documented to be associated with waterborne transmissions. Okay, another types of organism is alga, which is the example is Volvox, Eugila, Chlorotella, Synedra, Cholera, Anabena, Helminths. For descriptions, size diameter 1 to 102 micrometer, negatively charged surface, aerobic mortar and non-mortar. Also helminths, diameter size also 1 to 102 micrometer, negatively charged surface aerobic mortar. For remarks, algae are common living organism in water supply and play important part in a nutrient cycle, but a few algae are pathogenic to humans because it produces endotoxins that can cause gastroenteritis. Effective treatments and disposal of sewage water can control the parasitic worms in water supply. This is E. coli. When we see through the microscope, scanning electron micrograph of E. coli isolated from river water. Okay. E. coli is also known as a facultative anaerobic bacterium. Is found in the feces of healthy cattle and is transmitted in a lower intestinal tracts of warm-blooded organisms, including humans and animals. And most of the E. coli strains harmless colonize the gastrointestinal tracts of humans and animals as a normal flora, and also are defined as a pathogenic bacteria that produce single toxins and cause the life-threatening. The table show the treatment method to remove the E. coli, such as titanium dioxide, photocatalysis, slow sense filtration (SSF), and silver nanoparticles absorptions, riverbank filtration (RBF), GEC and ozonation system, ultraviolet radiations (UV), and biosonics on grassland. Okay, for all the treatments method, they have a positive side and the negative side. From this study, for the treatment method, the most effective treatment is titanium dioxide, which is the treatment for E. coli is nearest to 100%, which is 99.996% reduce the E. coli from the water. And also another one is riverbank filtration (RBF). So it can remove 99.8% for the total coliform and 99.96% of E. coli. Okay, for RBS, water treatment process by means of a compounds natural filtration processes through the aquifer. Okay, so the negative side of the titanium dioxide TiO2 and RBF is for TiO2, the required high light intensity unaffected by the initial bacteria. For RBF, the negative side is left the E. coli residue in water, especially hydrophilic fraction, and it's the consistent problem of removal in the monsoon climax, which is the raining season. Okay, so they have two types of method, conventional and non-conventional. So conventional, such as coagulations, flocculation, sedimentation, filtration, and disinfections. For non-conventional, use more sophisticated equipment. In Malaysia, we use the conventional method such as coagulations, flocculation, sedimentation, filtration, and disinfection in our water treatment system. This is the riverbank filtration RBF. The schematics are diagrams of mechanism in natural filtration by RBF system. So we can see the borehole here, borehole, and rechargement. This is a mixing borehole here. This is a mixing. We have the hole here. The filtration, biodegradation, absorption, chemical precipitations, and redirection happen here. And the mixings here, groundwater flow. This is a bank filtrations from the river. And this is the recharge, in-stream bioaccumulations and biodegradations. So riverbeds accumulation layer. And then the water is the absorption here, and the bank filtration here. So the difference by hydraulic gradients that cause the water from the river to flow towards the well during the pumping process. Then the IVF process is known as the sustainable and economical methods to improve poor surface water quality. Then the high quality of raw water is then supplied to the water treatment plant. Then it's making it easier to be treated at low operating caused by conventional treatment system. Okay, this is a procedure of a RBF. So we have a methods, objective, and major finding, and also the reference. So modeling of the changes in water chemistry during the bank filtration. The objective is to simulate the evolutions of a dissolved redox sensitivity and sensitive species in the case of a bank filtration. The major finding is a changing of the water chemistry during the transfer through the sediments. Low water velocity combined with the high input of particulates, organic carbons from the sewage treatment plant. So modeling quantitative, this means the evaluations of transport and natural alternations processed during the bank filtration. The objective of the modeling quantitative is to calculate the effects of natural alternations during the bank filtration using filtrat. The finding of this modeling quantitative, it can prove robust can apply to both confined and unconfined categories of aquifer. It also can apply in more complex situations, including a clogging layer, galleries of pumping and recharge well. For the basic geochemical analysis, the objective of bank geochemical analysis is to determine the percentage compositions of river water. Then the finding to increase groundwater chloride concentration from 35% to 40% of the groundwater is induced from the river. Heat flow modeling to investigations the temporal variability of riverbed hydraulics. The finding is to increase of Kb can increase the risk of aquifer contaminations and increase the river stage rising limb. Also in a KV occurs immediately after peak stage. For organophosphates and hydrophilic ethers, so the objective is determines the sustainability of organic traces. The finding is organophosphate more readily attenuate compared to the ethers and the possible applications of this ether as environmental organic traces. Ozonations, the objective is to clarify the precursor substance responsible for NDMA formations. What is NDMA form and remove subsequent biologically active at 30 to 50% of DMS in drinking water treatment. So for radar sensor, it's using to monitor of the environment and potentialities of the sensor. Then the finding is the radar sensor possible to deal with intended and low structured environment. So reverse osmosis subsequent activated carbon filtrations to access the robustness of a drinking water treatment plant. And the finding is a highly remove most of the organic micropollutants. So sand filtration, crossing the upper layer clay layer in RBF system, then it's acts to evaluate the efficiency of using sand filtration in contaminant attenuation. Then the major finding is to mobility of higher organisms connected with the redox conditions in the aquifer. Emissions of coliform bacteria reach to 100%. This is E.coli removal via riverbank filtration. For E.coli removal, a series of physical, chemical, and biological processes is improving the quality of the surface water. The fecal and total coliform are bacterial indicators that are widely used to monitor microbial water quality. Majority of the RBS system used in European countries and America alike have achieved an excellent total coliform removal percentage range from 99.2% to 99.99%, 2.1 to 5 logs. Okay, this is drawback of RBF treatment system. This for implementation of RBN has high potential to ensure the long-term productivity and stability of the water supply. It also significantly remove the degraded as the infiltration water move from the river or lake. It also has a good pollutant attenuations, then to remove the pollutant and dilute contaminant concentration during the infiltration processes. The variability and variability. The removal efficiency of a RBS system is influenced the climate change, temperature, natural and organic, dissolved organic and particularly organic matter composition of the surface water. It also in the extreme climate condition also influence the redox condition in RBF system that I said earlier, that RBF will have a change in when the climates have a changing, such as a raining of a sunny day. Okay, RBF cannot replace waterworks treatment processes compared to the traditional water treatment. So the main disadvantage of RBS limitation in a specific pollutant removal capacity and requirement for seepage residual time. Thus, in public water supply system, RBS is only used as a pre-treatment step. Okay, result and discussions. Compared to the achievement in the management and construction of the RBF in Western Hemisphere, this is still a large gap in Malaysia because RBF is not popular method in the treatment water in Malaysia nowadays. A lack of specific management standards, operation technology guidelines, and waterworks construction standard for the riverside groundwater source. Because in Malaysia we use more surface water than the groundwater source. The application of RBS in Malaysia has only just begun. That I said earlier, there is still a large gap in Malaysia, not widely used in Malaysia. Pressure in terms of treatment costs and increased demand on the existing water treatment plants. Only a few efforts have been made so far to understand the RBF mechanism and process, and also the gap in water absorption knowledge on RBF needs to be explored in order to provide better alternative for water security sources. For the conclusions, in order to understand and develop further knowledge of on RBF, the USM research team embarked on the study of RBS and different patient emotions. The pilot projects that has constructed in Selangor, Perak and Kedah. The results from the proposed analytical model are well matched with the data collected from the RBF sites in France. After these validations, the model has been applied to the first pilot projects of the RBS system conducted in Malaysia. Sensitivity analysis results highlighted the importance of the degradation rates of contaminants on groundwater quality, for which higher utilization rates leads to the faster consumption of pollutant. Mustafa et al. 2016. The development perspective of RBF in Malaysia is promising, with the establishment of a management system, improvement of the monitoring system, reinforcement of legal protections, and promotion of civics awareness. Malaysia RBF will play an important role in development of the water resource industry. For acknowledgement, the author would like to acknowledge the Centre of Research and Innovations, Department of Polytechnic and Community College Education for providing TVET's research grant scheme on E.coli removal via low frequency electromagnetic field in riverbank filtration, ERGS IDK 2146. Thank you.